Hey guys, welcome to EOC Explained. Let's rock and roll, jump right into it. We're going to do question number 6. Give you guys a second to read the question. Pause it if you'd like. Alright, let's rock. Alright, so question 6 says, which of the following statements best explains the process of energy conversion and takes place in the mitochondria? So again, we are awesome, and as awesome people do, we highlight. We highlight stuff that looks important. So there's a couple things we looked at when we highlighted. We looked at the process of energy conversion, and then, of course, where it takes place, which is the mitochondria. When I think of mitochondria, I think of what mitochondria has to do with, and that is cellular respiration, which is us, right? That's what we do. We do cellular respiration. So then let's think of, okay, what is cellular respiration? Well, it's essentially taking energy, which is the first thing we highlighted, converting it into a more usable form of energy, right? So there's actually a lot of energy in food, in the bonds in the food. If you've ever, taken a bag of chips, or not even a bag, just a chip or two, and lit it on fire as a kid, boom, it's going to light up. It's going to cause a lot of fire, and it's going to release a lot of energy. Well, there's energy in those bonds. Oh, I got set up. There's energy in those bonds waiting to be released. You just have to convert it into something usable, right? So we take that energy, we eat it, and we convert it to something that we can use. So let's look at the formula for cellular respiration. The formula goes as this: C6H12O6 plus O2 yields CO2 plus H2O, and then of course energy is the main purpose of this thing. Alright, so what do all these things stand for? Some of them you're probably familiar with, and some of them you may or may not be. Alright, first big long, the longest thing with a bunch of letters and numbers, that is carbs. That is your carbs. It's essentially your food, right? O2 is oxygen. CO2 is carbon dioxide. Di means two. Notice there's two oxygens there. And then of course H2O, most people know what that is. That is water. And then energy is made in this process. So, all right, so here we go. We got a better picture of this. Everything's all set up. Another thing to note that is the left side are the reactants and the right side are the products. So just think of it like you're looking at a factory. You see car parts go in on the left side. You see fully made cars come out on the right side, and then maybe some exhaust fumes from the whole process getting put together, right? So to rephrase that into something that maybe it makes a little bit more sense, reactants equal needs, products equal makes, right? All right, so with that being said, let us look at F. Of course, we highlight it again, as highlighting is awesome. Here we go. First thing, energy is required. So there's two things that I'm looking at. Let's go ahead and read the whole thing first. Energy is required for carbon dioxide molecules to form 6 carbon sugar molecules. Whoa, what is that? 6 carbon sugar? I don't know what the heck all this is. But no worries, alas, it's not a big deal. Let's just think about it logically, and we'll break it down. All right, so first thing, energy is required. Okay, let's look at our formula. Which side is the energy on? Well, it's on the right side. That's the product. In other words, that's the make. Are we trying to make energy overall? Yes. But as far as our formula goes, it's on the right side, right? And the right side is the make. So that's already wrong because energy isn't required for this. It's made, right? Let's look at the second thing we highlighted. Forms a 6 carbon sugar molecule, or 6 carbon sugar molecules, right? Well, again, where is the sugar? On here it says glucose, and on our last side said sugar or carbs, same thing, whatever. So where is the sugar, right? Is it on the right side or the left side? Well, it looks like it's on the left side for cellular respiration, right? So in that case, it's a need. It is not formed. When you form something, it's like you form this out of Legos. You build it. You form something out of clay. You build something. So that's building up or making or producing, right? But that's not formed. It's needed in this reaction. So that is not it. There's 2 reasons why F is not the correct answer. Let's X on out of that one. All right, let's look at G. Water molecules and radiant energy are necessary for anaerobic respiration to take place. All right, so again, we have 2 reasons why G is probably not the right answer, or actually is not the right answer. All right, water molecules and radiant energy are necessary. Bam, we can just stop right there. So again, what's water? Most people know H2O, right? So then let's look at my formula. Reactants on the left, products on the right. we know needs and makes. I see water on the right. That means water is what? It's a byproduct. All right, so we'll go into this a little bit deeper in just a second. So, but more or less, look, water's on the right. It's made. That means it's not needed. So that's wrong. It's already wrong. But let's check it out and make sure it's super wrong, right? All right. For anaerobic respiration, you see the second thing we highlighted in G, anaerobic respiration. All right. So before we even figure out what that is, let's take off the A and the N, and now it's just aerobic, right? So what do we think about when we think of the word aerobic or aerobics? Hey, let's go do some aerobics. Most people think, okay, we're going to go into a room, we're going to jump around and follow the person dancing in the front of the room. Well, yeah, that's what the average person thinks, and it's true more or less, but aerobics means you are using oxygen. It's a term for the process, and literally I think it means with oxygen, right? So if aerobic means with oxygen, what do we think that anaerobic, the word that we highlighted, means? Well, probably the opposite, right? It means without oxygen. So they're saying with that word that this process is done, this reaction is done without using oxygen. Well, again, let's reference our formula. And as we said earlier, this process is what we do. So, do you need oxygen? Absolutely. Which side is oxygen on? Is it there at all? Of course it's there, and it's on the reactant side, i.e. the needs. So we know, again, that it is not an anaerobic process, right? Okay, so that's two reasons, again, why G is not right. But let's break this down in, because I know there's oftentimes questions, and they see the cellular respiration formula and say, okay, well, I see that H2O is a product. It's more or less a waste product. Well, I thought we needed water. I mean, we need water to survive. So why is this water a waste product in an energy process? Well, in your cells there is tons and tons of chemical reactions going on constantly all day, right? Sometimes a byproduct of that chemical reaction is something, yes, your body uses, but for that instance, it's a waste product, right? So, there we go. Just put this into perspective. You essentially, you have the answer to this question in yourself. You're doing it all the time, constantly. What do you need? You need food, and you have to breathe. You have to breathe in oxygen. And your byproduct, do you breathe out? What do you breathe out? Carbon dioxide. Bam. If you hold your hand close to your mouth and you breathe out, it's probably a little bit moist, right? Unless you're really dehydrated. Well, that moisture is water vapor. That's a waste product of the cellular respiration. So, again, there's your, if you need proof, there's your proof of that. So, there we go. We know that G is wrong. So, let's go ahead and, let's take that out. We just saw the right answer. Let's keep going anyways. All right. H. Oxygen molecules release energy in the form of heat during combustion reactions. Okay, well, let's think about this one. Do you heat up when you eat? Yeah, a lot of people usually do. Sure, absolutely. So heat is one byproduct of breaking down this food. Is it a combustion reaction? We don't really have to know this. It is actually a combustion reaction because it does use oxygen to kind of break this stuff down, but it's a very, very slow combustion reaction. So it's not like the one in your car where it's, a bomb blowing up or something, or a fire. It's a slow process. So those two, okay, they got some right there, but don't let those throw you off. This is the key to this, right? Oxygen molecules release energy. Okay, oxygen molecules actually do not release energy. The energy, as we said earlier, remember we were talking about burning the chips and stuff. The energy is in the glucose, so the energy is actually in the food. That's the energy we need to convert, right? So oxygen doesn't release the energy is in the food. So that's what makes this one wrong, right? So good deal. We didn't get tripped up by that. All right, let's look at J. Let's seal the deal. The energy in the bonds of glucose, i.e. sugar, food, are transferred to the phosphate bonds in ATP. Awesome. So we know this is right because we know that our body makes ATP. That's essentially our battery. We eat sugars, we eat some foods. It charges the battery to ATP. And we won't go into it too much more than that, but that's all we really need to know. This is our formula. You eat sugar, you need oxygen. You breathe out CO2, waste product, also water. and end product, end result is energy. So we have solved the problem. Again, we are geniuses. Have an awesome day.